Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry involving in finding out the equation of a plane, right? So here we have a problem and we have to find the equation of a plane with some given conditions, right? So let us first read out the problem and then we will solve this problem. So here the problem is find the equation of the plane passing through the points minus 1 comma 2 comma 0 and 2 comma 2 comma minus 1 and parallel to the line x minus 1 over 1 is equal to 2y plus 1 over 2 is equal to z plus 1 over minus 1. So here we are given 2 points and the equation of a line, right? So here we have to find the equation of a plane. Let us draw the plane. This is the rough diagram and let us denote this plane by P, right? Okay, and now this plane P is parallel to this line, right? So let us draw the line like this, and this is the line L, right? And the equation is given by this expression, and these 2 points lie on the plane, right? So let us call these two planes as these 2 points as A and B, right? So the coordinates of point A are minus 1 comma 2 comma 0 and the coordinates of the point B are 2 comma 2 comma minus 1, right? So now here our aim is to find out the equation of this plane P, right? So equation of plane P is to be obtained, and we know from three-dimensional geometry that the equation of a plane is given by this equation, that is ax plus by plus cz plus d is equal to 0, right? So an equation of this form in x, y and z always represents a plane, right? So here the equation of the plane is ax plus by plus cz plus d is equal to 0, and we have to find this equation. It means we have to find the values of a, b, c and d, right? And we are given the conditions, that is this point A and this point B lies on this plane, and this plane P is parallel to this line L, right? So when a plane P is parallel to some given line, then the normal to the plane P is perpendicular to the given line L, right? So if we draw the normal to this plane P like this, suppose this is the normal vector n, and this normal vector n is perpendicular to this line L, right? Because this plane P is parallel to the given line L, right? So this is an important concept here. And now see here, this point A lies on the plane P, right? So the point A lies on the plane P. So the coordinates of this point A must satisfy this equation, right? So let us call this equation as equation 1. So here we must keep one thing in mind, that this A and this B are different from this quantity A and B, right? So here A and B just represents the point, right? So this point A lies on this plane P. So this point must satisfy this equation. So we have x is equal to minus 1, y is equal to 2 and z is equal to 0, right? So when we substitute this point in this equation, see what we get. We'll get a times minus 1, then we'll have b times 2, then we have c times 0 because z is 0 plus d is equal to 0, right? And if we simplify it, then we get minus a plus 2b and plus d is equal to 0, right? So let us call this equation as equation number 2. So here c times 0 is 0. Okay, now let us take this point B. So B lies on the plane P, right? So when this point B lies on this plane P, then it must satisfy this equation. So again we have x is equal to 2, y is equal to 2, and z is equal to minus 1, right? So x is 2, y is 2, and z is equal to minus 1. And if we substitute this point in this equation 1, then we'll get a times 2, then we have b times 2, then we have c times minus 1 plus d is equal to 0, right? So let us simplify it. So we'll get 2a, here we'll have 2b, then we have minus c plus d is equal to 0. So let us call this equation as equation number 3, right? So now from these 2 points we have obtained 2 equations, right? So this is the first equation and this is the second equation, right? So now what we will do, from these 2 equations we will try to eliminate d, right? So for this what we will do, we'll subtract 3 from 2, right? So 2 minus 3, it will give us, see here we have minus a and here we have minus 2, plus 2a, right? So minus a minus 2a is minus 3a, then we have 2b and here we have 2b. So these 2b and 2b get cancelled, and then we have here minus c, so minus and minus becomes plus, so we have here plus c, and here d and d get cancelled, so we are left with this equation, right? That is minus 3a plus c is equal to 0, right? So let us call this equation as equation number 4, right? Okay, so now we have this equation in which a and c are related as c is equal to 3a, right? Okay, so now see here we are given one more condition, that is this plane P is parallel to this line L, right? So now if we take the equation of this line L, then we see that we can write this equation of this line L as x minus 1 over 1. From here we can take 2 common, so we can write y plus half, and the 2 which we have taken common, we can cancel it out by this 2, so we are left with only 1, right? And here we have z plus 1 over minus 1, right? So this equation can be written like this. And if we compare this equation with the standard equation of a line, that is x minus x1 over a, y minus y1 over b, z minus z1 over c, then we see that a, b, c are the direction ratios of this line L, right? So the direction ratios of L are given by a, b and c, right? And a, b, c, when we compare these 2 equations, we see that we can take a as 1, b as 1, and c as minus 1, right? So a is 1, b is 1, and c is minus 1, right? Okay, so we have obtained the direction ratios of the line L, right? Okay, now from this equation 1, we see that the coefficients of x, y and z are the direction ratios of this normal vector, right? So the direction ratios of the normal vector are given by the quantities a, b and c, right? So here we have a, b and c, because if we have any plane P whose equation is in this form, then the coefficients of x, y and z always represents the direction ratios of the normal vector, right? Okay, now we see that this normal vector this normal vector is perpendicular to the line L, right? And we know that from vector algebra that when two vectors are perpendicular, then we have the condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0, right? So when two vectors are perpendicular, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0, where a1 b1 c1 are the direction ratios of the first vector and a2 b2 c2 are the direction ratios of the second vector. So now if we substitute the values of these direction ratios and these direction ratios in this equation, then we get a times 1 plus b times 1 plus c times minus 1, right? And this is equal to 0, right? So if we simplify it, we get a plus b minus c is equal to 0. So now here we have this equation, so we'll write it like this: a plus b is equal to c, right? So we can call this equation as equation number 5, right? Now see, from this equation, that is c is equal to 3a, we can substitute this value of c in this equation, right? So what we will get? We'll get a plus b is equal to 3a, and now if we solve this equation, we'll get b is equal to 3a minus a. So we have b is equal to 2a, right? So from this equation and from this equation, we see that c is equal to 3a and b is equal to 2a, right? Now from this equation, we can write c over 3 is equal to a, right? From this equation. And from this equation, we can write b over 2 is equal to a, right? And now if we combine these two equations, then we can write a is equal to b over 2 is equal to c over 3, right? And a can be written as a over 1, right? So now we have this equation, right? So a over 1 is equal to b over 2 is equal to c over 3. And now if we take all these three ratios equal to lambda, lambda is some scalar, right? So a is equal to lambda, then b can be written as 2 lambda, and c can be written as 3 lambda, right? So now we have obtained the values of a, b and c in terms of lambda, right? So now what we will do here, see in equation number 2, we have minus a plus 2b plus d is equal to 0. And if we take a is equal to lambda and b is equal to 2 lambda over here, we can obtain the value of d in terms of lambda, right? So let us substitute the value of a and b. So we have minus lambda, then we have 2 times 2 lambda plus d is equal to 0. So this is minus lambda plus 4 lambda plus d is equal to 0. So this is 3 lambda plus d is equal to 0. So d is equal to minus 3 lambda, right? So here we can add the value of d as minus 3 lambda, right? So viewers, here we have obtained the values of a, b, c and d, right? A, b, c and d in terms of lambda. And now we can easily substitute these values in equation number 1 to get the desired equation of the plane. So now let us substitute these values over this equation. So we have the equation of p as lambda times x, then we have 2 lambda y, then we have 3 lambda z, and d is minus 3 lambda, right? And that is equal to 0. Now see, in these 4 terms lambda appears, right? And since lambda is a non-zero a number here, so we can divide both sides by lambda, so that we can get rid of lambda. And now the equation of this plane P, it looks like as x plus 2y plus 3z minus 3 is equal to 0, right? So this is the Cartesian equation of this plane P, right? We can also write this equation as x plus 2y plus 3z is equal to 3, right? So viewers, this is how we have obtained the equation of the plane as x plus 2y plus 3z is equal to 3, right? And now if we compare these two equations, we see that the direction ratios of the normal are given by direction ratios of this vector n are given by the coefficients of x, y and z, that is 1, 2 and 3, right? And suppose if we want to change the Cartesian form into vector form, we can also write it as a vector r dot this vector n is equal to d, right? So this is the vector form of the plane P. So here we can write vector r dot, and vector n can be written by using the direction ratios of this normal vector n. So we can write I cap plus 2j cap plus 3k cap, and that is equal to 3, right? So this is the vector equation of this plane P, right? So viewers, this is how we can solve this type of problems.